This is Bob Capetta from the University of Illinois at Chicago, and this is Math 121 Pre-Calculus Final Exam Review for Part 1, Problems 15 through 18. We are given the fact that for a triangle, the secant of theta is 3. We want to find the other trig functions. Well, if secant is 3, cosine of theta is 1/3. We know, of course, that cosine of theta is x over r, which would make x 1 and r 3. So drawing our picture, there's the x of 1 and there is the r of 3. We need to find y. We will get that with Pythagorean Theorem. 1 squared plus y squared is 3 squared based on x squared plus y squared is r squared. So if that's the case, 1 plus y squared is 9, y squared is 8. So normally speaking here, we would say y is plus or minus the square root of 8, but we're in a triangle, so we know that y has to be positive. So we'll say y is the square root of 8. And then we'll simplify that for us, which is going to be root 4 times root 2, or 2 root 2. So now we have x is 1, y is 2 root 2, and r is 3. That should be enough for us to find all of the other trig functions. So next, sine of theta is y over r, 2 root 2 over 3. Tangent is y over x, so that's 2 root 2 over 1, or 2 root 2. Now regarding the others, secant is the reciprocal of cosine, cosecant is reciprocal of sine, cotangent reciprocal of tangent. So let's use all that information. That's what we know. Secant of theta, of course, is 1 over cosine. So the reciprocal of 1/3 would just be 3. Cosecant of theta is 1 over sine. So the reciprocal of sine is 3 over 2 root 2. Which isn't wrong, but let's clean it up a little bit. We're going to rationalize the denominator to make it look a little prettier. Multiply the top by root 2 and the bottom by root 2. So 3 times root 2 upstairs, 2 times root 2 times root 2. Well, root 2 times root 2 is 2. 2 times 2 is 4. We get 3 root 2 over 4 for cosec theta. And then cotangent theta is 1 over tan. Tangent is 2 root 2. So 1 over 2 root 2. Similarly to cosecant, let's clean this up, multiplying top and bottom by root 2. So 1 times root 2 is root 2. Root 2 times root 2 is 2. Times 2 is 4. And we get root 2 over 4 for cotangent theta. So notice we have all 6, 1, 2, 3, 4, 5, 6 trig functions when we started with secant of theta is 3. That was our given thing. Next we have the point 5, negative 12. We want to make a triangle with that point, so over 5 down 12, and then find the various trig functions for the angle defined by that point. So over 5 down 12. There is the hypotenuse, it'll call it r, and there is theta, the angle that is made. X squared plus y squared is r squared will help us solve for r. So 5 squared plus negative 12 squared is r squared. 25 plus 144 is r squared. 169 is r squared. R is 13. It's got to be positive, so negative 13 doesn't make sense. R is 13. So we have a triangle that will be 5, negative 12, 13. Once we're here then, cosine of theta is x over r, sine of theta is y over r, tangent of theta is y over x. So making all those substitutions, x over r for cosine would be 5 over 13. Notice that's in the fourth quadrant, and cosine is positive. Sine of theta is y over r, negative 12 over 13. Again, notice that's in the fourth quadrant, and sine is negative as we expected it to be. Tangent of theta is y over x. Tangent of theta y, negative 12 over x over 5. Again, in the fourth quadrant, tangent is negative. To get secant, cosecant, and cotangent, take the reciprocal of all of these things. Secant of theta is 1 over cosine, so 1 over cosine is 13/5, taking the reciprocal of that. Cosecant is 1 over sine. The reciprocal of negative 12/13 is negative 13/12. And cotangent we'll just think of as the reciprocal of tangent. Reciprocal of negative 12 over 5 would be negative 5 over 12. So again, we have all 6 trig functions, 1, 2, 3, 4, 5, 6, for a triangle that starts at 0, 0 and goes to 5, negative 12. Next, we have this graph of y equals negative 3 times the sine of pi over 2x plus 1. We want to find midline, amplitude, period, phase shift, and then sketch a graph. So let's go through that process. Now, the midline, that's the shift up or down, and we see the plus 1 here. So normally the midline of a sine function is y equals 0, but if we shift it up 1, the midline is going to have to be y equals 1. Now the amplitude is going to be defined by this, -3. So from peak to peak will be 6. So the amplitude is officially 3, but we don't want to lose sight of the negative here. So what I like to say is, yes, the amplitude is 3, but it has the same shape as y equals -3 sine x. So it's going to go down, go up, and then come back down, as opposed to +3 sine x, which goes up, down, and then up. So we'll keep that in mind. Yes, the amplitude is 3, but our shape is -3 sine x. Now the period is the interesting thing to look for. The period is based on this multiplier of x, sometimes called little omega. It looks like a W. This tells me how many cycles I get in 2 pi. So this pi over 2 multiplier tells me I'm going to have pi over 2 cycles in 2 pi. But I need to see what 1 cycle will be. So because the period is how long does it take to complete 1 cycle. So I've got to multiply both of these numbers by the same thing. I want to turn pi over 2 cycles into 1 cycle. Multiply by 2 over pi here, so multiply by 2 over pi there. 2 over pi times pi over 2 is 1 cycle in what? The pi's cancel. 2 over pi times 2 pi is 4. So 1 cycle in 4. So the sine function will complete a cycle as it ranges from 0 to 4. So our period is 4. Now phase shift, is x being shifted left or right? It is not, so there is no phase shift for us to worry about. So with all of this information, can we graph this thing? So there is our original function. We have an amplitude of 3, so the shape is -3 sine x. The amplitude is going to be -3. This is going to tell us how we're going to complete 1 cycle, then we're going to shift the thing up 1. Let's keeping that in mind. But I'm interested in the shape of -3 sine x. Let's look at a unit circle. The sine are the y values. Y value is 0, then 1, then 0, then -1, then back to 0. So the sine, again, x values of the unit circle. So I have a starting point, which is here, first quarter, midpoint, third quarter, ending point. So again, looking at the y values, 0 for the starting point, 1 for the quarter point, 0 for the midpoint, -1 for the third quarter point, 0 for the end point. But our shape is -3 sine x. So multiply all these numbers by -3. 0 times -3 is 0. 1 times -3 is -3. 0 times 0 is 0. -1 times -3 is +3. 0 times 0 is 0. So this will take care of my amplitude, and my period is 4. So I'm going to complete this from 0 to 4. So this will be easy. 0, 1, 2, 3, 4. Then I'm going to shift it up 1 at the end. So indeed our period is 4. Our midline, remember, shifted up by 1 with no phase shift. So there we go. Our first point was 0, the ending point was 4. That's our period. And then we saw, again, our first midpoint is down 3. So what did we do? We went for our first quarter point, down 3. Then our midpoint was 0. Midpoint is 0. Our third quarter point was up 3. Up 3. And then our ending point again was back at what? Our ending point again was back at 0. So we get all these. I've taken care of the period, and from 0 to 4. I've taken care of the amplitude of 3, shape of -3 this way. Only one more thing I have to do. I have to shift this up 1 unit. So take all of these points, move them up 1 unit, continue at least for 1 more period, and then connect the dots and see what those look like. So there they are, shifted up 1 unit. And here they are connected. We always want to have at least 2 periods. Here's 1 period from 0 to 4. Here is the second period from 4 to 8. So we always have at least 2 periods when we are graphing one of these trig functions. Next we have y equals 5 cos 1 over 3x minus 3. Same deal. We want midline, amplitude, period, phase shift, and then sketch the graph. Midline, shift it down 3. Normally the cosine midline is y equals 0. Shifting it down 3 tells me the midline is y equals -3. Amplitude here, 5. Amplitude is 5. So the shape will be the same as 5 cos x. We'll keep that in mind. Now the period is the interesting one. I have 1/3 here. So it completes 1/3 of a cycle in 2 pi. We have to figure out what the period is going to be based on that. So 1/3 cycles in 2 pi, I need to see what 1 cycle is. Multiply this by 3, multiply that by 3. 3 times the 1/3 cycles and 3 times 2 pi. 1 cycle in 6 pi, that's the period. Phase shift, x is not shifting left or right. No phase shift. Keep that relatively easy for us. Which brings us where? Let's put all this together. Amplitude is 5. The shape is y equals 5 cos x. Remember our unit circle, cosine are the x values. 1, 0, -1, 0, 1. So that's for the starting point, first quarter, midpoint, third quarter, ending point. But we need 5 cos x. So the starting point is 1, 5 cos x, 5. Quarter point is 0, 5 times 0 is 0. -1, 5 times -1 is -5. Third quarter, 0 again, 5 times 0 is 0. Ending point, 5 times 1 is 5. So here's where we're going to go. And what is our period again? Our period was 6 pi. So it's going to start here at 5 at 0, and then it's going to end at 5 at 6 pi, and then we're going to do our quarter point, midpoint, third quarter point. Midline again, y equals -3 with no phase shift. So here we go. 0 to 6 pi is our first cycle. And then what did our numbers look like for building this function? What did we have? Again, 5, 0, -5, 0, 5. Let's keep that in mind. 5, 0, -5, 0, 5. This ignores the -3, so the next thing I've got to do is I've got to shift it down 3. So I take all of these guys, shift them down 3 units, which we've done, and then connect them and try to have more than one cycle. And sure enough, that's what it'll look like. 0 to 6 pi is one cycle, and then to 12 pi is a second cycle. All right, now we're going to be given a graph. We've got to find the midline, amplitude, period, and omega. That's the multiplier, phase shift, and a formula for the graph. So here we go. Where's our midline? Goes down to -7 up to 1. So halfway between 1 and -7 would be -3. Notice it's 4 up to the top peak and 4 down to the bottom peak. So y equals -3 is my midline right here. Amplitude, 1, 2, 3, 4 from the midline to the peak, 4 from the midline to the peak, but it's going down. So the amplitude is 4, but it's got the shape, it looks sort of like sine. It's got the shape of -4 sine x. We want to keep that in mind. Period starts here. Where does it finish up? Finishes up there. So our period seems to be 4 pi. No phase shift. So let's put all this together to find an equation. Period's 4 pi, which means one cycle is in 4 pi. To get omega, we have omega cycles in 2 pi. So one cycle in 4 pi, omega cycles in 2 pi. 2 pi is omega times 4 pi. 2 pi divided by 4 pi is omega. 1/2 is omega. So we're going to look at 1/2 x will be our multiplier. So this is all we have. So we notice the same shape of -4 sine x, but our omega is 1/2. 1/2 goes there. And shift it down 3 units for our midline, and that'll be our function, putting it all together. One more of those. Same question. Here's our story. We are up to 6, we're down to -4. Halfway between 6 and -4, our midline is 1. Halfway between 6 and -4. So it looks sort of like a cosine function, and it completes one cycle from 0 to 6. Our amplitude, 1 up to 6 is 5. Down to -4 is 5. So our shape is like 5 cosine x. And again, our period is 6, completing it from here to here. And it has no phase shift. So let's put all this together if we can. Period is 6, one cycle in 6, omega cycles in 2 pi. One cycle in 6, omega cycles in 2 pi. So cross multiply. 2 pi is 6 times omega. 2 pi over 6 is omega. Omega is pi over 3. And we have everything we need now, so it's going to be cosine pi over 3x. Shape is like y equals 5 cos x. So it'll be y equals 5 cos pi over 3x to get that period, and then shift it up 1, and that will be our function. And that concludes this lesson.